All right, how about this first one? Which is the most, which is the least? What do you want to start with?
Glass of water.
What about a glass of water?
Contaminated with uranium. I mean, drink it.
So is that the worst or the most dangerous?
It
Or
would be the worst because you're ingesting it.
I agree with you that this would be number one worst, most dangerous.
If you drink it.
If you drink it, yeah.
Yeah.
Okay.
Sure.
Doesn't say if you drink it, so.
Sure. It's an assumption.
I didn't assume that, because you
All
try
right.
to drink sometimes.
Next. Why did you pick this one anyway?
Because you're going to drink it and it's going to be inside of you.
So,
And it's got uranium.
alpha. It's not that it has uranium, it's that it's an alpha emitter. That's what makes it the most dangerous. That this particular isotope, uranium-238, is going to be emitting a whole boatload of alpha particles inside of you. That's why it's the most dangerous. So, next.
Nuclear reactor.
Cosmic rays.
I'd say this would be number 4, the nuclear reactor. And that the microwave would be the least dangerous. I'd say cosmic rays were number 2. And the carbon-14 decay is number 3. Again, the alpha decay from the uranium-238 makes it the most dangerous. And then the cosmic rays are the highest form of light energy that you can get, so they're pretty darn dangerous. The microwave, it can't break anything, can't do anything to you, so we don't care about that one. The U.S. naval reactor, you stand right next to the thing and you hug the sealed door, nothing is going to happen to you. There's too much shielding going on there. The carbon-14, it's decaying inside of you right now, so it's there. All right. 600 gram sample of lead-210. You allow it to decay 1 gram to 1 gram. How long will this take? Okay. So what do you want to do?
Negative 22 minutes.
Somebody have a time?
It's 203 point something. There's like one sig fig there.
200 minutes? 1 sig fig?
203. 1 sig fig would be 200.
Yep. Good with that? What would be a pretty simple way to verify it?
Look at my kid.
You could plug it back in, sure, the equation. Or you could build that little table, 600 to 300 to 150, and work your way down till you get between whatever the one will fall between two of those at some point. All right. So we'll get a 750 gram sample, allow it to decay for 3 hours. All right, so there's a unit issue with this one, right?
Hours and minutes.
Yeah, so I'm going to make this 180 minutes just to get rid of the hour part. The equation for this is going to be N is equal to NO times E negative time natural log of 2 divided by the half-life. So it'll be 750 grams times E 180 minutes times the natural log of 2 divided by 27 minutes.
What is that, 2 sig figs? I mean, 3 hours.
Yeah, it's really only 1 sig fig.
Only 7.
All right, so 750 times E negative 180 times the natural log of 2 divided by 27, 7. Okay. Oops. What is a nuclear decay series? What do we got there? What do you want to say about that? About
That decay until they reach a stable element.
that example that we had with the uranium-238, you have to use the word isotope instead of the word element because lead is up there 3 times. But twice when it turned into lead, that was an unstable isotope. So it turned into something else and turned back into lead and it still wasn't right. Turned into something else, then turned back into lead, and that finally, when it hit lead 206, that was an acceptable proton to neutron ratio for that element. That's it, right? There's
Wondering
nothing.
why you left such a big space. I was like, am I supposed to? I wrote a whole paragraph saying that.
Okay. Boil water. We can't make our little suns. We don't have a container to contain our little sun. That's the problem. Yet we don't have a container yet. Yep, that's it.